मैं घूम लूं थोड़ा. Start? Sure? Yes. A very good morning to all. In today's session, we are going to learn what is all about sampling and sampling distribution and its various techniques. So let's begin with the few concepts to understand, that is population and sample, and how you distinguish between the population and sample. So population refers to an entire group that a particular researcher want to draw some inferences or the conclusions about the particular data set. But a sample is a specific group that a particular individual or the researcher will collect data from a particular data set or from the population. So basically, the size of the sample is always less than the total population. And that is a major difference between the population and sample, where the population refers to the entire group, where a particular individual wants to conclude about their data, but a sample refers to a specific group or a subset of the population where a particular researcher would like to collect the data from it, and that is called sample. So if you look up the particular, you can say pictorial representation of the population and sample, where the population is a large group, and within from the population or within the population, the selected sample is to be collected from the entire population. So when it comes to the research aspect or it comes to the research analysis, a population does not refers to a people. It refers or to a particular group or a particular community, which always includes the various elements of the population, or it could relate to be anything a particular researcher wants to pursue or wants to study, such as it could be objects, it could be events, it could be countries, it could be organization, it could be organisms, spices, etc. So that is the basic meaning of the population and sample. What would be the various examples where it could be distinguished between the population and sample? Let's see in the upcoming slide. So this is a various examples that how you distinguish between the population and the sample. So if we talk about the country or the countries, we are talking about the population in any of the aspect. Like take an example, the advertisements for the IT jobs in the Netherlands. So what would be the sample if we select the top 50 companies for the, you can say, advertisements for the IT jobs in the Netherlands on that particular date? That is exactly called sample. If we talk about the songs for the Eurovision Songs Contest, so whether it would be list down the winning songs from the Eurovision Song Contest that was performed or were performed in English. The third example would be the undergraduate students in the Netherlands. This is a population. On what aspect the data or the sample is to be collected from the students, that would be the sample. So if we take up the 300 undergraduate students from the 3 Dutch universities who are volunteer for your psychological research study, that is exactly the sample, because we are taking out the 300 undergraduate students from the population. We are taking up the winning songs from the population listed down. We are taking up the top 50 advertisement companies from the population. to advertise for the IT jobs, and they become samples. When we talk about the population, all the countries of the world, so we can talk about in any of the expect, it could be expect related to the birth rate or the GDP in the respective years that becomes samples. So the countries with published data available related to the birth rate and the gross domestic product since 2000 onwards, that becomes the sample of from the population. So this is how we can distinguish between the population and sample in respect of these four major examples. Next, we come up to the next concept is the population parameter and the sample statistics. So when we talk about the population parameters, so when a particular researcher collect the data from the population or you can say sample, so there are some measurements of the numbers that we need to calculate from the data. So automatically when we talk about the parameter, it refers to a measurements. It could be that particular describe the whole population, that is called parameter. But the statistics is also refers to a measurement that describes the sample. If we calculate the mean of 50 people or the 50 samples, then it refers to a statistics. So here, when we talk about the parameter, so parameter means when we talk about any of the, like for example, to study the psychological behavior of the students, it becomes the parameter because of the that describe the whole population. So I'm studying the psychological behavior of the university students. It's become the population parameter. If we calculate the 100 university students of their and along with its mean score, that's called sample or a statistics of the sample, or in other words we can talk about the descriptive statistics of the sample. We can also use the estimations or the statistics measures, like we can talk about the measures of central tendencies, measures of you can say dispersion, and or another aspect we can use the hypothesis testing, where we just generalize, you can say a major or pre-assume or declarative statement where we going to be tested. So it is very important to distinguish between the sample statistics and the population parameter, and how it difference, what would be and how it differs to each other. So we take up the research example where we can distinguish easily the population parameter and the sample statistics. So in your study of the students' political attitudes, so if we studying the students' political attitudes, you always, a researcher always ask a survey questions and put up a questions, you can say, from the participants to rate themselves on a scale that is 1 for the very liberal to 7 very conservative. So this is a rating scale from 1 to 7, where the 1 is called very liberal and the 7 we call a very conservative attitude. So automatically the researcher can able to find out the most of your sample identities are liberal. So after getting the data, it is being estimated that most of the students are actually liberal. So the mean rating, and once we estimated the mean of that particular sample on the political attitude scale, that is 3.2. So if we talk about the mean perspective, then we have estimated the mean of the sample, that is of the, you can say, of the university students, becomes the sample statistics. So you can use the statistics, that is the sample mean of 3.2, which is a scientific guess about the population parameter. And this 3.2, it always gives an information, which always gives a, you can say, the particular information and specific information about the whole population, that is the university students. So automatically population parameter will describe something about the whole population, and it always based on the sample statistics. If any mean, you can say, or any average of the sample is being estimated, that mean is always portrayed something about the whole population, and that's become the population parameter. So the population parameter is that the mean political attitude rating of all the undergraduate students in the Netherlands. So if any sample statistics or any result of the tool of the statistics like mean, median, and mode, if they always define something about the whole population, it becomes the population parameter. So this is how you can also distinguish between the population parameter and sample statistics. Now we can take up the next concept, that is the census and sampling. Census is always a process that how a particular researcher collect the data from each and every member of the population, and that is called census. You can always say check on when there is a surveys to be conducted among the population of India or among the Indian population, that is actually called census, because we include each and every parameter of the population to collect or include each and every member of the population. That's called census. Sampling is a process of collecting the data from a subset of population. So when like sampling, it is in the sampling, the data is being collected from the subset, from the small part of the population, that is called sampling. So in the census, every member of the population included, while in sampling, only the small group is to be selected from the population or from the census, so that who actually represent the whole population, that is called sampling. So this is also a basic difference between the census and sampling as well. So this is a distinguish between what is census and what is sampling, and in the particular census and sampling, what is the margin of error. So when we talk about the census include each and every member of the population while collecting the data, but sampling collecting data from a subset or any of the selected group of the population. For example, if a particular researcher want to collect the data from males and females, that is called sample. If the particular data is being collected, including each and every you can say member, including males and females and other particular genders of the Indian population, it's become census. So if you are selecting a data for either males or females, it becomes sample. Next one is census. It requires a large amount of resources and the time to conduct the survey and get the data. But when we talk about the sampling, it requires us less resources and it is very quick to conduct a survey because it involves a specific group of the population. Census provides a complete and accurate representation of the population because it covers each and every member. But sampling provides an estimate, an exact value, give an idea about the whole population based on that sample where the researcher has been selected about it. Next one is census is more expensive because it collects data, it It involves the, you can say, heavy expenditure, but sampling is very less expensive than the census because it involves a selected group of individuals. Census can be useful for a small population, and when a detailed information is actually required about the whole population, then census is more useful. Sampling can be useful for the large population, or a journal description is needed about such population. When we talk about the last difference between the census and sampling, what is the margin of error? The margin of error is a uncertainty, is a degree of uncertainty of your results which might have face. So if there is a larger the error would be, there rightly you are far away from the true figures for the whole population, and that is called the margin of error. So margin of error is typically very low, or is refers to a low margin of error census, as it covers the whole population. But when we talk about the sampling, it's larger than the census because the sample size is very smaller than the population size. So automatically the sample size is much lesser than the population size. In fact, the sample size, the size of the population is major large in the census, as it includes each and every member of the population. So automatically the margin of errors is actually more than the census, while you can say taking up the samples from the population, but the chances of errors typically or is very small in case of census method. So this is also one of the good example between how you distinguish between the census and sampling. So if you look up the census, where each and every member is involved in the particular circle, and sample is a selected groups is being considered and used to collect the data from that particular selected group. So for example, we can consider to find out a number of dogs owners, people above the age of 75. So we have to find out the people who have above 75 and how many dogs owners in this particular age group. So sampling is very opposite, and it includes a very small percentage of the population. But when we apply, this is a census where we include each and every member of the population who are having an age group of above 75, as it is a large group. So census is more accurate than the sampling, and it is more useful when we calculate or consider the data of a large group. And this example is perfect example of the census method. But when we talk about the samples, we can look at another example. A census counts all the movements in Texas and records their ages. But a sample is particularly randomly select 1,000 movements in Texas and ask each of them about their age. So this is a basic difference. So if we talk about or to identify the movements in taxes and record their ages, it becomes census. But sample randomly select the 1,000 movements in the taxes and ask them about their age, it becomes sample. So the sample, it offers or refers a basic estimate that how many movements in taxes whose age is above 75 or over, you can say 50, while a survey would identify exactly how many movements in taxes are over 50. So this is a basic difference about that the sample is not give you a exact or accurate calculations, but the census will give you an accurate calculation, as it is more useful than the sample, because sample does not include the entire member of the population, but Census will include the entire, but sample will not include, and that is the main difference between the census and sampling. So census is considered as it is a more expensive method because every member we have to involve if into different states or a different reason. So investment is more to involve resources are to be more to use, and that will be used in census method rather than sample. Now, we can talk about what are the sampling methods or sampling techniques. So we'll come on this concept. I already explained what is sampling, what is census, what is population parameter, what is statistic, sample statistics, all that. So now it is very easy to understand what are the different types of the sampling techniques or methods. So in statistics, when we talk about the sampling method or sampling technique, it's just all about just studying the population, how a researcher will gather the information, how they will analyze the data using such information or data of the particular or the selected group of members. So automatically it is a basis of the data where the sample space is enormous. Enormous is that the sample space is actually larger, which have a no count. So automatically, then in that particular case, the techniques will be applied. So there are several different sampling techniques available, and automatically it's divided into two groups as well. And all those methods of sampling automatically targets a particular easy, hard, or the you can say any type of approach to reach out the groups, to reach out the people, to collect the data from them. So this is a sampling methods. They're categorized into two groups. The first one is probability sampling, and the second one is non-probability sampling. The probability sampling is again subcategorized into four parts: the simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. When we talk about the non-probability sampling, is categorized into five types. The first one is Armenian sampling, consecutive sampling, quota sampling, purposive or judgmental sampling, snowball sampling. So before I come up to the major subcategories or the subtypes of the main types, that is probability and non-probability, it is very important to understand what is probability sampling method and the non-probability sampling method. The probability sampling method, it's that form of sampling where a particular researcher select the samples randomly or on a random basis, where all the eligible individuals have an equal chance to being selected, you can say, for the particular study, and that is called the probability sampling method. This method is requires more time. It's become expensive, and that refers to a probability sampling method. But the one benefit, it always gives a overview or gives a satisfaction to the researcher that it guarantees the sample which refers to a representative of the whole population. So that is called the probability sampling method. The next one is non-probability sampling method. Is a technique where a particular researcher select the sample based on their judgment, based on subjective in nature, rather than random selection. So there is no random selection in the non-probability. Whatever the sample is to be selected based on the subjective or the judgment in nature. So in this method, all the members of the population may not get an equal chance to select the sample from the whole sample population. So that is called the non-probability sampling method. So this is a basic difference between the probability sampling and non-probability sampling, where the probability sampling requires time And of course it requires expenses, while the non-probability, they don't require uh, funds, they don't more time consuming as well. Automatically probability based on random selection, but the non-probability is not based on random selection. So whatever the members being selected have an equal chance to involve being as a sample in a given study. But non-probability, you can see all the members may not get an equal chance. In fact, they will be selected based on the judgments and subjective in nature. So this is a basic difference between the probability sampling method and the non-probability sampling method. Now now I'm talking about the various subcategories of the probability sampling method or techniques. So the first category of the probability sampling, or the first subtype of the probability sampling method, is a simple random sampling. In simple random sampling technique, every item of the population has an equal chance or a likely chance of being selected in the sample. That means in a simple random sampling, every member of the population is being involved or get an equal chance to be selected in a given study is called simple random sampling. In fact, since automatically whatever the items or whatever the sample is to be selected, it's totally dependent on the chances. And when any selection is based on the chances or based on the likelihood, that method is called method of chance selection. Why this method is being applied? If the sample size is very large, then the particular samples or the items is chosen randomly, then that is means it is also called a representative sampling. So if any sample is selected based on the chances or the likelihood of the selection, so automatically it becomes the method of chance selection. So if any sample size is more larger and any samples or the item is chosen randomly or selected randomly, then it also becomes the representative sample. So in this simple random sampling, there is a method is being used, that is chance selection method. And when the sample size is large, under this and the particular samples is selected randomly, it becomes representative sampling. So let's to understand more about this type with the help of the example. Suppose we want to select a simple random sample of 200 students from a school, and we can assign a number to every student in the school database for 1 to 500. So we use the random number generator to select the sample of 200 numbers. So we can take up the you can say 5 gap. So the first 5 students, that means then automatically the another 5 students, that means 5, 10, 15, 20, 25, 30. So we just generated the difference of 5, that every fifth item will be randomly selected, and that's called simple random sampling. Or just randomly we select every second item, that means every second sample will be selected, and that means it becomes simple random sampling. So automatically, if we have a database and we have to select the samples, randomly we select 200 samples from the 500 samples. So that is called the simple random sampling. So it's just a basis of the chances that, okay, this particular sample will get a chance to include, then on the fifth item will get a chance, a 10th item will get a chance. So we just randomly select the samples. Next type of the probability sampling is a systematic sampling. So when we talk about the systematic sampling method, all the items are selected from the targeted population, where the target population is based on the gender, it's based on the income group, it's based on the occupation group, by selecting or choosing up a simple random method, and of course any other method after the fixed sample intervals. That means automatically we can talk about, as I told, that if we choose 30 samples, so automatically 30 samples will be divided by a number of groups. So let's, for example, 30 samples is divided by the three groups. So the 10 samples will be selected from the whole population. So that is called the systematic sampling. So it is calculated by dividing the total population size by the desired population size. So let's take an example to understand the systematic sampling. Suppose the names of 300 students of a school are sorted in a reverse alphabetical order. To select the sample in a systematic sampling method, we have to choose some 15 students by randomly selecting a starting number, say 5. So automatically, if we talk about 5, we can talk about 10, 15, 20, 25, 30. So we have, you can say, automatically selected the number or a difference of 5, that is called the systematic sampling. So that is the major difference between the simple randomly, where the randomly we have selected the sample, whether it would be randomly decided a gap of 2, 5, 10. But here, if we have to choose 15 students out of the 30 students, then automatically we have to, you can say, and accordingly randomly select based on the starting number. So automatically based on the differences, that means a difference which is common among the all of the 300 students. That is 5 difference. We choose 5 difference. So automatically we have to choose the differences of 5. That means 5th to 5th item, 10th item, 15th item, 20th item, 25th item. So if we choose a difference of 4, 4th item, 8th item, 12th item, 16th item, 20th item, and that is called systematic sampling, where from the number 5 onwards, we select every 15% from the sorted list, and we end up with a sample of some students. So this is how the systematic sampling works on. So if we have a 300 students and we have to apply systematic, we have to decide a starting number, say 2. So every starting number from 2, we just select the difference of 2 item. That means 2 item, then 4th item, then you can say 6th item, 8th item, 10th item, and accordingly we just collect the data, collect the samples from the selected items only, and that is called systematic sampling. Next one is stratified sampling. When stratified sampling means where the total population has been divided into small groups, so that the complete sample process would occur. So small group, it would be based on the I think is believed the characteristics of the population. It could be gender, it could be you can say based on the occupation, income group, meritable status, gender. So automatically it's all about the characteristics in the population, that how the small group is to be formed or to be classified. So after separating the population into the smaller group, now statistician or the job of the statistician or researcher randomly select the sample. So let's take an example to understand this particular type. So there are three bags A, B, C, and every three bags have a different balls. That is, bag A is 50 balls, bag B has 100 balls, bag C is 200 balls. And we have to choose a sample of balls from each bag proportionately. Suppose 5 balls from bag A, 10 balls from bag B, and 20 balls from bag C. So automatically, if we select the samples from each bag, then automatically it's become stratified sampling, where the whole population is divided into three bags, and within three bags, the balls, that means a characteristic of the population, is also being divided, and that's called stratified sampling. Now, with the next type of the probability is sampling is cluster sampling, where the groups of the people are automatically being classified based on the reasons, location, state, etc. So in the cluster sampling method, the cluster or the groups of people are formed from the population set, and such groups has a similar characteristics as well, and every group, you can see, have an equal chance of being a part of the sample. So automatically under this cluster sampling, you can use the simple random selection method. Let's take an example using this concept. An educational institution has 10 branches across the country. If any researcher wants to collect some data regarding the facilities and the other things, so automatically a researcher cannot travel to different branches into a different locations, or you can see different states of the country. So you just use the random sampling to select 3 or 4 branches as clusters. So cluster is a particular group based on the reasons or the locations, and accordingly researcher select the data, collect the data from the selected samples into 3 or 4 branches. So this is a graphical representation where we talk about the simple random sampling. As you can see, there are 12 samples and randomly we have selected. That is 2, 5, 8, 10. Systematic sampling, as we can talk about here, systematic, where the particular differences is always being equal between the samples. So if we have chosen, let's suppose we have chosen 2, then afterwards we choose the 5th item, as there is a difference of 2 samples. Same again, we can choose 8, then we can choose 11. So here we are selecting the samples in a very systemized and organized manner by a difference of 2 samples. So it is called the systematic sampling. Next one is stratified sampling, where a particular groups, where we can divide the population into a smaller groups we can talk about. So here there are actually, we can talk about the 2 population are classified into 3 groups, into green, purple, and yellow. And from all of the, you can see 3 groups, we just used a simple random selection method and choose the samples within these 3 groups. So that is called stratified sampling. Cluster sampling, we just divide the population based on the location, based on the branches as clusters. So clusters is all about the any type of locations, the area we can talk about. So there are around 12 samples, and out of the 12 samples, randomly we have chosen, according to our random selection, we have choose only the 3 or 4 branches or the locations or the states, because these states, locations, branches are called clusters. So automatically, if there are 12 states and we have chosen 4 states, so 4 states as clusters. So that is called the clustered sampling. Now we can talk about the non-probability sampling techniques. So the first one is convenience sampling. So in the convenience sampling methods, where the samples are being selected from the population directly, just based on the researcher convenience, whichever is available, wherever the samples are available, and it is convenient for the researcher to collect the data, that becomes the convenience sampling. And the samples are easy to select, and the researcher did not choose the samples which definitely that outlines the entire population. So there's not necessary to outline the population. It's just based on the convenience, and it is very nearer to your place, or you go and collect the data. So let's take an example to understand this concept. In researching customer support services in a particular region, so a particular you can see customers definitely have put up a various questions to complete the survey. So the researcher will ask the various questions to the few customers to complete or finish the survey on the particular products after the purchase. So it is very convenient way to collect the data, as they have used the product and they just reach to a mall or any other reason. You visit there and immediately you get that data from that particular customers. And that's called the convenience sampling, because at the same time, such samples may not represent the whole population, and that's called the convenience sampling, because whatever the samples you have collected according to your own convenience, or where the samples are easily available to the researcher. The next one is consecutive sampling. So as you can see, the sampling technique in research, there are plenty of the samples or the selected group of the samples is already shown, then where the participants are selected, then accordingly, and whatever the selection is to be done is based on the availability and accessibility, where the researcher can access to that particular place and easily the data easily the samples are available, so that the researcher can collect the data, and that becomes a consecutive sampling. So consecutive sampling is very similar to the convenience sampling, very slight differences. In this particular time, the researcher picks a single person or a group of people for the sampling purpose, and the researcher select or researches for a period of time according to analyze the result and move to another group if needed. Let's take an example to understand this concept. A finance researcher investing the spending habits of the customers at a local branch bank branch. So due to the time restrictions and the constraints, the researcher need a timely data. So what he will do, the researcher opts for a consecutive sampling approach. So over or within a month, the researcher approaches the customers as they enter into the bank. That means they are easily access into the bank, invite the customers to participate into the study, and those customers who are easily agree or available into the bank, the researcher will collect the data. They will use the data for their own researches, how they will analyze the data and conclude the results. So automatically those customers who agree and meet up the inclusion criteria of the study are having an active account to a bank, then they consequently participate or included into the sample. So this method is always allow the the researcher to efficiently collect the data from the customer who are readily available, and the particular researcher can easily access into that particular place. In this example, like that research, in this particular example, the researcher is easily access into a bank. That becomes consecutive sampling. So convenience, it's according to the convenience, the sample is easily collected from the by the researcher. Consecutive, where the availability and the accessibility easily get to the researcher to collect the data at a particular place. So that becomes a consecutive sampling. Next is quota sampling, where in the quota sampling method, the researchers forms a sample where the individual will represent the population based on the specific traits or the qualities of the population, where the researcher chooses the sample or a selective group that brings the useful collection of data, where and using that data, it will generalize the population, where the suppose the concerned universities having the 10,000 students, and that is the population. And with how the particular researcher divide that population into the various categories, and from the various categories, they will decide the proportions, and according to the proportions, they will collect the data from that proportion is actually called the quota sampling. So let's begin an example to understand the quota sampling. We need to know the career goals of the university students. So the difference, as we can see, always the differences in the career goals of the students, and the three main categories has been examined: fresher, juniors, and the seniors. And the concerned university contains the 10,000 students and constitute our population. So the researcher has divided the population of the 10,000 students into three categories, that is freshers, juniors, and seniors. And we find out there, we have also find out that there are 3,000 freshers, 2,500 junior students, and 2,000 senior students. So automatically our sample must have these proportions. So proportions is already been estimated: 30% of freshers, 25% of the, you can say, juniors, and the seniors are the 20%. So automatically 7,500 students are available in the school out of the 10,000 students, and the samples is being selected according to their proportions only. So if we sample the 1,000 students, so if a particular researcher wants a 1,000 samples, a 1,000 students, or the data of the 1,000 students, so accordingly we just calculate the proportions of the three categories, that is fresher, junior, and senior. So automatically 300 for the freshers, 250 for the juniors, and 200 for the seniors. So here we have divided the population based on the career goals of the university students, and that is called the freshers, juniors, and the senior students. And what would be the quality of the population is the career goals. So whatever you divide the data, you divide the population based on the specific traits, or you can see the factors or the qualities, it becomes quota sampling. So we have decided the population and divide the population based on the quota, that is called the career goals of the university students, and divided into three major categories, that is fresher, juniors, and seniors. And accordingly is been the data and sample has been collected, and that's called the quota sampling. Next one is purposive or the judgmental sampling. When we talk about in the purposive sampling, the samples are selected only based on the researcher knowledge. So whatever the sample is selected, if the particular, you can say, respondent or the participant is knowledgeable, the researcher will get the sample from that particular participant. So as the knowledge is very important, so that creating the samples and the chances of obtaining the higher accurate results would be possible without any major errors. And that is, in other words, we can call a judgmental sampling and authoritative sampling. The next and the last type of the non-probability sampling techniques is the snowball sampling. Snowball sampling refers to a chain referral sampling technique. So if a researcher select one sample and that samples belong to the more other references samples or their friends or friends to friends. So researcher if take a sample of samples to friends, samples to more samples of their friends than their relatives, it becomes a chain referral sampling. It's become snowball sampling. So in this method, the samples have tricks. It's very difficult to find out the same categories of the samples. So automatically, if one sample is selected and the sample is referred to their friends, to their relatives, to their friends to friends, related to relatives, so easily the researcher can collect the data from all of them, and that's become the snowball sampling. So each identified member of the population is asked to find the other sampling units. That means their friends, their relatives, their cousins, and that has become the sampling units, and the researcher will collect these other sampling units, and so that which always belong to their whatever the target population has been selected by the researcher, and that's called snowball sampling. So these are the main difference between the probability sampling technique and the non-probability sampling technique. Probability sampling techniques where every member of the population have an equal chance to be selected in a given study. Non-probability, not all the members will not get an equal chance of being selected into a study or for a study. When we talk about the probability sampling method, they are called the random sampling methods, but they are called the non-random sampling methods as well. Automatically, where they are used for researches which is conclusive, where the conclusion would definitely comes out from the study. But when the case of the non-probability sampling, it's used for research which is exploratory. So the whatever the research is to be done, just try to explore more and more virtue of that particular study. Probability, it always takes a long time to get the data, but non-probability is an easy way to collect the data quickly. Hypothesis testing is always involved in this particular sampling methods, and the objective of such methods to validate such hypothesis, to prove such hypothesis into a study. But non-probability sampling method, the hypothesis definitely it's to be designed, it's to be conducted in case of non-probability sampling, but the hypothesis can be concluded after the study as well too. But in the probability, this hypothesis to be formulated before the study starts or before the study begins. But not in case of the non-probability, hypothesis can be generated, can be formulated after the study later, and that is called a non-probability sampling in case of. So this is a basic difference between the probability and the non-probability sampling methods. Now we come up to the what is sampling distribution. So sampling distribution we can talk about is a finite sample distribution which have no and actually. So it is a probability, in other words, it also refers a probability distribution of a statistics based on the random sample selection of from a given population. And of course, when we talk about the sampling distribution, here we are talking about the distribution of the data, the distribution of the frequency, that how far the you can say the possible outcomes would comes for a specific population, and that is called the sampling distribution. As the population is very large to analyze, so it's better off to create a smaller group and again to you can say repeat a smaller group and analyze them, and that is called sampling distribution. So where we just calculate of one value, and that one value of one estimation represent the whole population. So that is called the sampling distribution, where the probabilities is need to be calculated, where the descriptive statistics, the measures of statistics like central tendency, dispersion, you can talk about the various measures of statistics like t-test, z-test, or the probability distributions. Like I already taught what is normal distribution, binomial distribution, which always comes to calculate when it comes to calculate the probabilities of a given event or a given data. These are the small important terminologies in sampling distribution. What is statistic? It is a numerical summary or descriptive statistics of the data of a sample. We can talk about the mean, median, standard deviation, etc. Parameter, I already explained. Sample, I already explained. Population, I already explained. Sampling distribution. Here we are just distribution of the statistics across multiple samples, that each samples have a different statistics, a different descriptive statistics, different mean, different standard deviation, different median, mode. That is called the sampling distribution. Suppose I have collected data of 10 samples, and every 10 samples having a different mean score, standard deviation score, median score, mode score. That's becomes sampling distribution. Another important concept is central limit theorem. This is a very basic theorem in statistics where the sampling distribution of the sample is actually of the sample mean. It's basically tends to be a very normal as the sample size increases. So this theorem states that as the sample size increasing, whatever the statistics comes, it tends to be a normal. This is called the central limit theorem. And how this theorem will apply, what would be the formula being used, that will be, you can say no, and that will be very important to understand. Standard error. Standard error, it means that any errors occur or any changes of the sample statistics around the population parameter, that becomes the standard error. Base is a error in terms of estimations, in terms of conclusion to estimate, which leads to a changes of the estimated statistics. That's become base. Confidence interval, it is a range of the values is calculated from the sample data from the population parameter with a certain level of the confidence. Sampling method, it is a technique to use or select the sample from the population. It could be cluster, convenience, and any other method. Inferior statistics is a statistic methods or techniques is really used to draw up the conclusion or make inferences about the population based on the sample data. Hypothesis testing is all about the declarative statements or the, you can say, decisions or making up the conclusion about the population parameter, which is also based on the samples. And of course, whatever the assumptions has been formulated before the study starts, and that assumption and that declarative statement, it need to be proved by using a statistical tools that's called hypothesis testing. So these are the basic terminologies which is mainly used in the sampling distribution and easily understand the major concepts of the sampling distribution. That is the central limit theorem, how we can use or calculate of the samples in a particular study, and what would be the formulas is being used which is related to the mean, standard deviation, which is very easy to understand. So this is how these terms would be used in sampling case. So thank you for all listening this lecture. I come up to the more and relevant topics related to the upcoming lessons. So till time, thank you for listening this lecture, and namaste to all.